Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's Algebra 2 class. Today we're going to talk about word problems, and this is just part one. Okay, I'm going to break this up into 2 to maybe even 4 parts, depending on how long it takes for me to teach each section. I'm not worried about the speed. I'm definitely worried about the content here. Okay. Today we're going to start talking about just direct translation word problems. Now, you've already been exposed to some word problems involving direct translation, and those were in the form of percents. If you guys remember, what percent of a number is 56? And you had to be able to know how to convert the word of to multiply, is to equals, set the equation. So you've already started working with equations, all right? But in order to understand and work with word problems, you must first learn how to translate words into mathematical terms. First things first, though, remember that an unknown is a variable, and usually it is expressed as x. It does not matter, though. You can express a variable in any letter or symbol you want, technically, okay? It's anything you want. I'm not trying to be sarcastic, but if you wanted to make a variable a little star symbol, you could. As long as you told me what that star symbol represented, that would be fine. But usually we use x. A lot of people like to use n. It's really up to you. Now, correct me if I'm wrong, but when we did the percents, I did go over phrases, right? So this will be quick. I just wanted to give you a refresher. So thank you for your honesty. That way we don't waste so much time. I know I like to repeat things sometimes, but I repeat them on purpose because I know these are the things that are important. So when we're talking to addition, guys, as we've described before, any of these words are a potential for addition. Sum, plus, greater than, more than, exceeded by, in excess of, added to, increased by, combined, all together, together, total of. Okay? These are very popular words for addition. Know them. Okay? Know them all very well. Yes, sir. Thank you. Mm-hmm. When they say combine, that's yeah, that's gonna be addition, because even if the variable, let's say you said a number x is combined with a number y, even if one of them is positive and negative, you're combining them, you're adding them together. Excellent question. Thank you, my man. Does that make sense, guys? With addition, right? And like I said, I'm not trying to bore you or make your life miserable. If you know this already and in your heart you know it, I'm not going to make you write it down. If this is kind of like, oh, I forgot all of this, then maybe it's a good idea to write it down. Okay, my brothers? Thank you. So subtraction, we got difference between, difference of, minus, less, less than, decreased by, fewer, subtracted from, subtracted by, fewer than. If you guys remember, though, the big words of the day here are less and less than. So if I were to tell you guys, give me 1 second, please. Okay, sorry about that. If you remember less and less than, a lot of people get this mixed up. So what if I told you a number less 6? What does that equal? X minus 6, very good. And then if I said a number less than 6? Yeah, so you just switch. So remember, less than means switch. Good, you guys got this. And there you go. So that's subtraction. You with me? All right, awesome. Thank you, gentlemen. Okay, next. Multiplication of times multiplied by product of. Per has a little asterisk. I'm going to explain that to you now. Twice, double, triple, half. Increased by a factor of, decreased by a factor of. Okay? Of is the key there. Very popular for multiplication. Now, why did I put a star around per? Because per can be used for multiplication and or division depending on the question. If I told you that it was $10 per CD, and I said you bought 5 CDs, how much did you spend? 10 times 5, which is 50, exactly. So you knew that you had to multiply there, right? Because you took the price and you had to multiply it by the number of CDs you bought, correct? So that's why per could be multiplication, could be division. How would it work for division? It would work like this. They said you spent $20 on CDs that are each worth $5 per CD. How many CDs did you buy? In that case, you'd have to divide, yeah, because you take the 20 that you spent divided by the $5 each CD, you bought 4 CDs. Does that make sense, y'all? Okay. And then last but not least, it's bored. Okay. Quotient, divided by, divided, per, ratio of. So per can be interchangeable depending on the question. So please be careful to read. Yes, sir, my brother. Come again? No, half of would not be division. I mean, well, it's technically one of those because if I said to you half of x, it's 1/2 times x, which technically means x over 2. So I guess, yeah, that should have a little asterisk because they could be used for both. If I took a total and I half of the total, I'm technically multiplying 1/2 times the total. But when I multiply a half, I'm really dividing as well by 2, right? So in that case, it could be interchangeable, kind of. But it's technically half of a number, you're multiplying 1/2 times that number. Does that make sense? Thank you, sir. Okay. Yes, sir. No, thank you. What's up, buddy? Okay. Let's do another example of the per. I'm going to tell you right now. Let's say that I tell you that it's $5 per CD. Okay? You bought 5 CDs. What would you be doing here? I want to find the total of how much I spent, and you bought 5 CDs, and each CD is $5. How much did you spend, my brother? 5 times 5. You just answered your question. That's $25. You just multiply, correct? Because per CD. Give me a second. I'll get right to you on the division. Does that make sense with multiplication in the moment? Thank you. Does that make sense to everybody, guys? It's an important question. Okay. No, bro. Why are you saying sorry? Because you care? No. You never apologize for caring. Now let's continue with this. It's $5 per CD. Okay? You with me, my brother? But you spent $30. How? That's a weird W. How many CDs did you buy? What would you do there? No, there's no 6 here. Division. You spent $30 divided by $5 per CD. You bought 6 CDs. Does that make sense, my brother? Takes a lot of guts to ask. Thank you. Very, very, very welcome. We're good so far? And then equals, guys. What's the deal with equals? You guys, anyone remember? Is, was, are, were, will be, would be, gives, yields, sold for. Any tense of is or to be. Any tense of to be, basically. That's what that is. Yes, sir. No, you don't bother me. What's up, my man? It's sold for. Yeah, because that's what it's sold for. That's what it equaled. The couch and the chair together sold for $80. That means that I bought the couch plus the price of the chair. That totaled $80. Yes, but they're not always going to use the word equal, my brother. So that's why you're going to have to know how to recognize these words, because if it's sold for, like I said, I bought the chair that I had plus the table that I had sold for $80. Correct. And this combination sold for that, so that combination equaled the 80. Yes. These two, okay, this sum that you sold for 80. Sold for means it's equaled 80. Because the sum of these two was $80. So it sold for $80, so that sum equaled 80. Combine the prices of the chair and the table, and that gave me 80, which is the sold for price. Make sense? Thank you, my man. Good? All right, now, let's see what we got here, okay? I just want you to start going little by little. Write the word phrases of numerical or algebraic expressions. How would I write the sum of 3 times a number and 8? Tell me, there you go, 3x plus 8. Yeah, this is going to be easy. Let's go. The difference of a number and 9. Who can tell me that? Difference of a number and 9. Excellent. Excellent. Who can tell me the product of -4 and 6? -4 times 6. Yeah, that's awesome. How about the quotient of a number and 2? 9? No, no worries. I was a little confused. 9. Thank you, my brother. Great job. How about 9 less x? 9 minus x. How about 9 less than x? Yes, because I flip. That less than means flip. Switch it around. Last term goes first, first term goes last. 3 times the sum of a number and 15. What you got there? Sir? Yeah? Yeah. Fantabulous, guys. This is 3 times the sum. So it's the sum. You're multiplying that 3 times the sum of a number and 15. Does that make sense? This is the number one mistake. People will say, oh, 3 times the sum of, oh, so it's 3x plus 15. Oh, man, and it breaks my heart when they do that because I know they had good intentions. But what is this technically really saying? 3 times x plus 15. But what is this one saying? 3 times the sum of x plus 15. Does that make sense, guys? Okay, I swear I'm not trying to bore you. I just really want to make sure that this year, you really walk out of here knowing word problems, like for real. I don't care if you're a master, but I want you to walk out of here with at least the notion of, no, I get it, man. I can translate words. Sir, my brother. Stop apologizing. Go. Yes, if I said a number, okay, if I said, okay, what my boy's asking is for this one here, he wants to know when would it be a negative. So what do you guys think? When would that be a negative instead of a positive? What do you think you would say? I haven't done this one yet, my man. But for this one, I still want to do what I said. How would I change this plus sign to a negative? Yes, sir. Yes, I would say 3 times the difference of a number and 15. So if I wanted this to be negative, it'd be 3 times the difference of a number and 15. Does that make sense, y'all? Okay. Thank you, guys. Now, let's continue. A number decreased by 35. Bam. X minus 35. Does that make sense, y'all? May I continue? Okay. Write each word phrase as a numerical or algebraic expression. All right, let's see what we got here. The Dolphins scored P points in the football game. Well, we know that's a lie because that would mean that the Dolphins actually scored points. Um, no, I'm kidding for all Dolphin fans out there. Out there, come on. The Dolphins gonna win the Super Bowl? Oh, we're not in math anymore. We're in fantasy land. That's nice. No, I'm kidding. I'm kidding. I know there's a lot of people out there watching going, oh, why is he talking on the Dolphins? It's because they're not good. No, I'm kidding. I'm kidding. I love my Dolphins, okay? I love my Dolphins. Proud of the Dolphins. Okay. The Dolphins scored P points in a football game. The Jets scored 12 more points than the Dolphins, clearly. And then write an algebraic expression for the number of points the Jets scored. Okay. What is it going to be? Okay, 12 plus P. Everyone knows that. Very simple. But I'm going to start showing you guys how to really make direct translations simple for the rest of your life, no matter what words they're using. Go ahead. Correct, because you're combining the points. But that's why I want to teach you guys how to make a little table. Okay? Tables are so powerful. I know I'm super annoying about tables. I'm going to drive you crazy with it. I'm telling you right now, have patience with me. I always do this, and I very rarely get word problems wrong. I'm going to say M for Miami, J for Jets. How many points did Miami score? How many points did the Jets score? 12 more than the Dolphins, right? P plus 12. Now, you will all probably going to say, yeah, Moro, that's what we told you. I get it. But trust me, I promise you, as things get more difficult and difficult, you're going to really be happy that you start using this table. Trust me, okay? Next, a lumberman cuts a 50-foot log into two pieces. One piece is Y feet long. Express the length of the second piece as an algebraic expression in Y. Sure. Okay, but remember, it said expression. I'm super proud of you, but let's be clear. Expressions do not have equal signs. So it'd be 50 minus Y. Now, brilliant. I maybe didn't understand that. Maybe someone out here doesn't understand how he got that. So let's just make this simple. There's one piece, and then there's piece two. And I know that the pieces were cut into two, right? The 50-foot long piece was cut into two pieces. Do we know how long the first piece is? So, really? Yeah, you know. Okay, so what do we call something we don't know? Okay, in this case, they want to express in Y. Now, think about this logically. I have a 50-foot piece of wood. If I took off 30 feet, what do I have left? How did you get that? So if my first piece is Y feet long, what does my second piece have to be? 50 minus however long that Y piece was. Does that make sense? This is the beginning, no joke, no sarcasm, of greatness. If you can start seeing this, you can develop these tables, you're going to breeze through word problems. Does that make sense? Yes, sir. How did I do that? Well, I've got a 50-foot long piece of wood, right? I cut it into two pieces, right? Do we know how long the first piece is? So we call that Y. Now, wasn't it a 50-foot piece of wood? We don't know anything. We know that there's one piece of, hold on, don't interrupt. There's one piece of 50, right? One 50-foot piece of wood. Yes or no? Okay. Let's just use numbers. If I cut it into two pieces, and this is 20, what does this have to be, my brother? No. Do the math. The whole thing is 50. I cut 20 feet off of it. What am I left with? Papa, I got 50 feet of the whole entire piece of wood, right? I cut it into two pieces. One of the pieces is 20 feet. What does this piece have to be? 30, because you subtracted. So you have, in this case, a 50-foot log. You're cutting it into two pieces. Do I know what the first piece is? No, you do not. It does not tell you. This is why you do not know what that piece is. But the other piece is 50 minus whatever y you took out. Because you're trying to find both pieces. Does that make sense? We're trying to find both pieces. Okay, give me 1 second. Okay, guys, thank you for that. Excellent questions. Okay, now, next. The number of quarters in a drink machine, this is where it starts getting good, is 2 less than the number of dimes D in the machine. Write an expression for the number of quarters as an algebraic expression in D. Did I get you yet there? Did I confuse you there? No, you got this one? What is it? B minus 2? D minus 2. Very good. Look. Check it out. I've got the number of quarters in a drink machine is 2 less than the number of dimes. So we're talking about quarters and dimes. Now, what do we know nothing about here? No, you know something about quarters. You know that quarters are 2 less than the number of dimes. What do you know nothing about? So we call that D. 99% in direct translation word problems, the second value is usually the one we know nothing about. I would almost say 100% of the time, but I'm sure there's a problem out there that's going to defy that. But I'd say 99% of the time, when you're reading a direct translation, this is 4 more than that. This is twice the, twice the amount of half of this. That last variable they're talking about is usually the variable you know nothing about. So if D is dimes, it's okay, perfect. What do we know about quarters? 2 less than the number of dimes. So how would I do 2 less than D? D minus 2. Does that make sense, my brothers? Yes? Thank you. May I continue? Yes? D, because do you know how many dimes you have? That's my variable. I don't know. I have D dimes. I have no idea how many dimes I have. But I do know something about quarters. I know that it's 2 less than the number of dimes I have. So it's D minus 2. Make sense, Baba? Right. But here, in this case, I specifically wanted you to use D. But yes, you could have used X or Y or W or whatever you want. Okay? Thank you, my man. Thank you, my man. When keywords, okay, is, are, was, were, will be, gives, yields, sold for, just to name a few, are added to an expression, it becomes an equation, okay, which can actually be solved. All right, and this is where we're going. All of this is building blocks, guys. I hope you notice we haven't touched a single word problem yet. All building blocks. I know it could be a little boring today, but please make sure you know these building blocks, and I thank you for your patience with me. Whenever you add an equal sign to an expression, it becomes an equation. So I know that sometimes I'm a stickler, and I say, no, that's not an equation. It's not me being a jerk, guys. It's me being real. Algebraic expression does not have an equal sign. An equation does. So I want to translate each of the following sentences into an equation. 5 more than a number is 20. Yes, sir. Bam. 5 plus x equals 20. A lot of people ask, Moro, could I do x plus 5 equal 20? What's the answer to that? Yes. What's the reason for that? What's the property? Commutative. Very good, my brother. Excellent, son. Yes, sir. You got a question, my brother. I'm sorry, my man. Oh, you want B? Tell me B, brother. So 4 times the sum of a number, and 3 is 15. Yeah, yeah, yeah. Bam, bam. That's it. Excellent. How about 5 less than a number is 45? My man. Nicely done, son. Less than, flip. X minus 5 is 45. Next, how about the difference of x and 5 is the quotient of x and 2? Yes, sir. Uh-huh. No. Is equals the quotient of x and 2. So what does it mean? Tell me. So tell me, what do I write, my brother? Thank you. Awesome. Good job, kid. Does that make sense, y'all? Okay, may I continue, y'all? Now, it's probably where we're going to end after this page. Let me see. Yeah, probably, and maybe we can actually get to the starting examples. All right, let's see what we got. Maybe. Let's see. Okay. There are 5 main categories of word problems, and of course, we're not going to learn them all today or even in this chapter. All right? You have direct translation. This we are going to destroy in this chapter. There's problems in which we must translate from English words into the language of mathematics by using keywords found in the problem. They usually involve a comparison between 2 or more entities. You know, the amount of red paint was 2 less than the amount of blue paint. Anytime you're going to have some sort of a comparison, okay, you're going to go ahead and use direct translation. Geometry problems. We're going to do some like that here, some like that here. Problems in which unknown quantities are related through geometric formulas. You must memorize these formulas. We're going to have a whole day on this, so this will be taught for this test as well. Mixtures, okay. I can teach mixtures, guys, using direct translation. I'm going to be honest with you. The book wants me to teach it in this chapter. I'm going to choose to not listen to the book right now. For me, the way I teach mixtures, it's much easier to teach with systems of linear equations, and we're going to get to that soon, but not yet. Okay, but I just want you to know it's out there, it exists. We're not going to forget about it. Uniform motion, we're doing it for this test. Oh my goodness. 3 times the charm, there we go. Okay. Uniform motions are problems in which the formula D equals RT, where D equals distance, R equals rate, and T equals time, okay, is involved. So when we have distance, rate, and time, those are uniform motion. We will be doing those this test. And last but not least, you have what's called work problems. And this is problems which 2 or more entities join forces to complete one job. Again, they want you to do it in this chapter. I don't think that the skills that we have are going to make it very easy or productive. So I'm going to make an executive decision as to skip this part until we get to what's called rational equations. So of the 5, we're going to knock out 3. Okay, so I'm excited. All right. And those are the types of word problems that you can work with. Now, last thing, the general strategies for solving word problems, and this will be the last thing we do. On Monday, we will start right here where it says direct translation word problems, okay? So step 1, let me just put them all out so you have it, and I'll explain it now. Identify what you are solving for. Guys, I can't tell you how many times really smart kids, okay, grinders, they're working hard. They come to me and they're just confused because they don't read. Read. Figure out what you're solving for first. If you don't know what you're solving for, it's extremely difficult to get the answer. Number 2, label the unknown variables carefully. I've been saying label to you all year. You're sick of hearing me say label. I'm going to continue. Label, 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 label. Label what it means. What does that X mean? What does that Y mean? What does the Z mean? What does the W mean? Label. Translate the word problem into an equation or inequality. Use the skills that we just went over today. Translating words to math. Use that skill, my brothers. Use it. Make sure your answer is reasonable. This is probably the most important part aside from labeling. I had a student one year. We were doing, I forget what it was. I think it was a geometric problem. And we were looking for an area. And he got something ridiculous. You know, human error. He got something like, we were working with numbers like 12 and 15 and 20. And somehow he got negative 3,022 was the area. And he put that, like, he was happy about it. He didn't stop to think about the reasonableness of it. Can you have a negative area? No. If we're dealing with percents or discounts, and there's a 20% discount off of something that's $300, can it be a $600 discount, guys? No. Okay, that's double the price of what the original item was. So use reasonableness. Make sure that it's reasonable. And then, I know it seems obvious, but guys, answer the question. Okay? Find the value of the missing variables. Sometimes you will get a solution, but that is not necessarily the answer to your equation. For example, let's say that we were talking about, remember that 50-foot wood example? So piece 1, piece 2, this is y, this is 50 minus y. Let's just say that you figured out that y equaled 30, just for giggles. Okay, and I asked you though, what is the size of the second piece of wood? You would have gotten this wrong had you said y is 30. Now you're going to say, but Moro, that's y. I did not ask for y. I asked for the second piece. So it would really be 20. Read the question and answer the question. Thank you so much for your patience, guys. I know it was not a super exciting class. God bless you. I hope it helped, and I hope you learned a lot. Have a great day. I'll see you on Monday. What?